Hello, students. Today we are going to talk about machine learning. My name is Dr. Neeraj, and today we are having a small project which is to predict whether the customer is good or bad for a bank to give loan. So the bank wants to give loan to a customer, and what are the chances that the customer will repay the loan? If he repays the loan, if the probability is high to repay the loan, the customer is good. And if he is not going to pay back the loan, then we want to avoid him. So this is what we have to classify whether he is a good customer or a bad customer with the help of Python machine learning module. Now the thing is that we have previous data which is having around parameters, 28 parameters are there, which will decide whether the customer is good or not. And the target variable, the dependent variable, is either good or bad. Binary logistic regression we will do. So 0 is good customer and 1 is bad customer. So let us see this. First step is, this is VS Code, Microsoft. It is ID, and we are going to type our what do you call this? The program in this. Yeah, this is Python, and it is free to use. It can be downloaded easily. Now, basic assumption of this tutorial is that you have some idea about Python and you have some idea about machine learning. Then only you will understand this. But I will try to make it simple. So what I've done is I've put some steps over here. These are the steps which we will go through one by one to make this particular model, machine learning model. And this is basically into marketing because it is business related, and this is a mix of machine learning and marketing project. So first step is to import the libraries and packages of Python. So what we will do is import numpy as np. Then what we can do is import pandas as pd. Then from sklearn dot preprocessing import standard scalar. Again, from sklearn, let me write this. From sklearn dot linear model import logistic regression. Then model selection import test train test split. And the one more is there, matrix import we can import confusion matrix. Then accuracy score, then precision score. Yeah, I think that's it. So let us now try to run this particular thing. I hope there is no error. Okay, it just started. So connecting to the kernel. Now we have to change the current directory to the directory where we have saved our data file. Where we have saved our data file is, let us go to the file. This is the folder, and this is the another folder, and this is our data file. So I will change the working directory to this one. So what is the working directory? Should be where our data file is. So our data file is in which directory? It is here. Let me copy this, and okay, tick has come. And now we go to this one, second cell, and we import OS, and then we write OS dot change directory, and we write the path which is I have copied. Now I'll paste it here, and we have to change the direction of slash, because Python does not accept the slash for the path. So this can be different for you. You have to just go to this wherever your file is. You will go to properties and copy this location, and you will put it here simply, and then you will just run the cell. Okay, there is some syntax error. What is the error? Invalid syntax, and it is starting from here. Okay. So what we have to do is we have to put it in the commas, which I forgot. I hope this will help. Yeah, now we have changed our directory to this particular directory as our working directory, and that is good. Let me put it in aeroplane mode. Yeah, so now next step is to import the file inside the Python system. So let us import it by, say, we already have we have this pd as pandas as pd, so we'll write here pd dot, that is pandas dot read file, read, and we are having Excel, so I've used Excel. It can be CSV also. And then what I'm going to do is oops, yeah, and I will just write the name of the file here. What is the name of our file? Data file. Our data file is this one. Control V, Control V, and we will import the data file. Okay, one thing I did a mistake. Data file is not defined. Okay, it should be in commas, and we will save this data file into a variable data frame, and we will run it. So again, there is a mistake. It happens. There is no such file as this thing. Okay, what do you mean by there's no Excel file? Okay. Dot X, yeah, and let us run it. Okay, now next is check the first 5 records of the data. Which data? The data file df. It is ticked, that means df has been formed. So let us see the first 5 records. So df dot head, and we run this. So we have first 5 records of our data file. This is our data file. So there are so many columns. These are all variables which will predict the target. Target is 0 or 1. 1 is bad and 0 is good. So we have to predict this in logistic regression. It can be binary logistic, it can be polylogistic. That means more than 2 categorization classifications are there. That is also possible, but we are doing binary logistics. Now this is our file and this is our target. These are our variables. Okay, now the checkout. Let us check out the shape of the data. How do we check that? df dot shape, control enter. 3000 rows and 30 columns. Now the thing is, like for example, in our logistic regression, I don't need this id because this is not a variable which will be used for predicting the target. Others are variables which are having some sense. id has no sense, so I will remove this particular column. So how do we do that? Drop the columns. So what we do is df dot drop what? Drop the column id. And is it column or row? It is a column, so we say axis axis equal to 1. 1 is column. Okay, see the column is gone, id is not there now. We will save this again, we'll mutate it to df, and again we do this. Again check the shape so that we know that it is mutated or not, or it is deleted or not. So again df dot shape, control enter. Now see, previously it was 30, now id is removed, so it is 29 columns. Now let us describe the data. Data means our df dot describe and control enter. So now see, it is showing the mean, it is showing the standard deviation, it is showing minimum, maximum, it is showing the quartile range, everything is there. So it is good to see the data. Now let me clear this output. Now next step is what? We have to find, is there any null values in this? Let us check that first. So what again we will do is df dot is n a, yeah, dots. We will sum this, n is sum, and we will press enter. Enter. So there is 188 zero values in this time last inquiry by the customer. 188 is huge. So we don't want any null values to be here, and the standard practice for data science is these are the null values of so many variables. We don't want this. So what we will do is we will fill this particular null value with the mean value. So what we do is df is equal to, again, df dot fill na, fill the null value with what? With df dot mean of the column. Yeah, and I hope it should work. Now again, let us okay, I have not done here, but I will do it. Let us again see the null values. Control, whether it has worked or not. Let us add one column here, and again control V. Again let us run it. See, there is zero null value now. So we have substituted zeros with the mean value. So this is our standard practice for data science and machine learning. Now we will define x and y. What is x? X is the independent variables and y is the dependent variable. We use the command ilog. I means location of that row and column. So what we do is x is equal to, we have to define first. Let me define y first. Y is equal to df dot ilog, that is a location, and then see in this particular when we are writing about location, there is a colon, there is comma, and on the left side of the comma it is rows, and on the right side of the comma is columns, row and columns. So we want all the rows, so we just write the colon here, colon comma. Colon means everything is, all rows are included, 3000 rows are included, and column. What is y? Y is our target variable. In Python, the first column is indexed as 0, not 1, 0. So what I will do is I will write it as 0, and I will press Ctrl Enter. Next I will define x How I define x? Df, again same thing, location, and then again comma is there. This is standard, sorry, this is standard thing. Before the before the comma is row, again I want everything, all rows. But what about column? First column is what? 0, yeah, already it is y. 0 is the first column, which is a dependent variable. Other than 0, the next one first. 1 up to what? 1 up to we have to see the shape. Let us see the shape. Here the shape is 29. So we just write 29. 29 is the last one. So we write 29. So from the second column onwards to the last is the x, which are independent variables, which will predict y. Let us enter this. That's it. Now let us see. See, you can see x and y if you want. You can write. Let me show you if you want. If I write say y, it will show. It is the first only one column. You can also see x. This is, you can see it later. And let us clear all the output. And we go to the next work, that is check if the data is balanced in terms of target variable. In machine learning, balanced data is good. Like 50% is success and 50% is failure. 50% is 0 and 50% is 1. But sometimes it does not happen like this. So let us see how balanced it is. So check if the data is balanced in terms of target variable by using value counts. So what we do is we see categories. I want a variable called category count is equal to, it can be any name, is equal to df dot df, not dot, df, and we are talking about the variable target for which we want to see that, the categories, how many 0 and how many 1, and then we write dot value counts and we press enter. This, yeah, sorry, I didn't mention this. So see, 0 is 2500 and 1 is 500. It is not balanced. 0, that means is success is more and failure is less. It is not equal. So this is called unbalanced or not balanced data. So we should know whether it is balanced or not. So we have found it by this way, and now we will make x train, x test, and y train. What is this training? We split the data into training and test data. Why we do this? Because first we will fit the model with the data. We need some data to train the model, fit the model. So we use training data. Say 80% of the data is for training and 20% is for test. Why we do this is because if I train the model with 100% of my data, then how will I test it? Because already the model is knowing about the data, whole data. So what we do is we hide some data from the model so that we can test it later because test has to be happen with unknown data. If it is known, then there is no test. Model already knows about it. Machine already knows about it, so it will predict very nicely. But if the machine is not knowing about the unknown data is there from outside, so we can test from that outside data, that is the data which we have separated from the original data. We never show it to the machine. That is called a test data. It is used for testing the model. So first we have to divide the data into training and test. So x independent variable will be having train and test, and dependent variable again will be having train and test. So let us do that. Here on the top, if you see clear, we have taken train test split from model selection. So this we will be using now. So we need to make this is equal to train test split, x is independent and y is dependent, comma, Then we say that what is the test size, that is 20%, 80% will be training. So we will make it 0.2, and then we will, we should have random state. Random state is equal to some number, because we are doing it for academics or for learning. So every time it will give the same result. It is good for us for, otherwise you will think why my result is coming different. Let me put any random number, say 11, and then stratify, because it is a unbalanced data. So what I want is x and y should also be in that ratio only. It should not be in the different ratio. It should be stratified similarly, and when we are making a test and training data, it should be with the same pattern as the pattern is there in the original data. So I will say stratify is equal to yes, and I will run it. Now let us see whether everything is good. So we will see x underscore test dot shape 600 rows and 28 columns. That means 20% is test. So out of 3000, 20% is 600. So it is correct. Again, x train dot shape. Again we enter this. Say 2400 plus 600 is 3000 rows. Columns will remain same. So like this you can see y test and even y train. So let me do it because it's good to see the information. 600 and again y train dot shape 2400 and 600. That is good. Now let us scale xtrain and xtest to standardize independent variables. Only independent, not dependent. It's not required to be scaled. Because why we are doing scaling? To standardize the data. Because some, columns will be having high values, bigger values as compared to other columns. So that will affect the model working. So we will make it standardized. It will be similar. Scale will be similar. So how do we do this? Xtrain equal to, okay, we have to standardize it. So wait. First, we will write SC is equal to standard scalar. From where the standard scalar has come? Again, we go back here. From sklearn pre-processing, import standard scalar. Clear all output. Now, SC is the standard scalar. Xtrain is equal to SC dot fit transform. And what is that? We have to fit it with Xtrain. We have to Xtrain. And again, X test equal to standard scalar dot transform. Here we will not use fit, because test data we want to keep it away from the model, because it is only for checking. If we fit it, it is like leaking the exam. So we will just write transform and we will write control enter. Now this is already scaled. Next step is we define the logistic regression as REG. So REG is equal to logistic regression. Control enter. And then we try to fit the model. REG dot fit by passing x train, which is scaled one, and y train. Now, if you observe, I have not used test because right now I'm fitting the model, I'm making the model learn. We are making the model learn from the data. And when I have to check whether it is good for generalization or not, I will use the test data. Test it, how good it is. So we have fitted the model again. Now we will use the predict function. So reg is our model, regression, logistic regression model. We predict. Now we will see the confusion matrix. Confusion matrix is equal to confusion matrix. We put y predict and y test. It's long. Yeah. So this is a confusion matrix. 486 and 28. We want it to be higher because these are the right predictions by the model. Higher these two predictions, 486 times it is true positive. 28 times it is true predictions. So this is what we want it to be higher. Now we'll find the accuracy of the model. We'll write regression model score and we will pass x test and y test. Now friends, we have to write test, not train, because we are finding the accuracy score now. We're testing it. And we enter this. 85% accuracy is good. But as you know that this is unbalanced model, so we will find the precision also. Let me delete this. Now we will find the precision score. We'll find reg dot precision. So we have written this precision score is equal to y test y pred, and we will enter this, and then we will see the precision. It is 66%. So see, what is the difference between accuracy and precision? Because accuracy is like, if you see the bullseye, accuracy is in the center. What is your target? How many you are able to achieve that in the center? That is your target. How many you are able to hit by the model? How much accuracy is there that it is able to achieve the objective of the variable in the center? Center is our target, and how many hits there on the predictions? That is accuracy. That is accuracy. What is precision? Precision is how close are the predictions. It may be far away from the center, but how close are they? So if the precision and accuracies are good, both are good in this case, so our model is good. Why we are saying precision also? Because our data is unbalanced. If it is balanced, even accuracy is enough. Now we clear all the outputs. Again we go down. Now we predict the target variable by passing the scale input to the model. So for saving the time, I have already taken this data. This is our input because so much I have to write. 28 variables or 29 variables are there. So let me put the scaled one. I have put sc.transform. I don't want the data to be non-transformed because everything is transformed. So input also has to be transformed, standardized. Now if you see this, here I have written 0.8. If you see the data, it is showing 80%. This is why I'm telling you is that if you write 80%, the data it will not show properly. It has to be 0.8. If 100% is there, you have to write 1. I will show you what it is. So we see the head. So one is the target. 15 what I've put is this row for this checking it. 9 3 okay, fine. See this 0.8. If you see the data file, I copied it from the data file. If you see the data file, if you copy from there, see this 15. I copied it from here to check. Now this dollar has to be removed. It should be 16,000. Dollar has to be removed. Otherwise it will show error. 80% if I write, it will show error. You have to write 0.8. If you write 100%, it will show error. Write 1 in decimal form. Then only, because model will take only numbers, not this percentage. Dollar sign is not required. So just want to tell you that. And now this is our scaled input. Okay. Say something. X does not have valid feature names, but standard scaler was fitted with feature names. Okay, leave it. Now if you have to predict it, let us predict it. Reg dot predict and scaled input. Press enter. So one has come. Now if you want it to be better customer friendly, you can write one small command. If uh, say scaled, let me one second. Let me put it here itself. If predict decision equal to this, if decision equal to 0, print. This is not required. If you don't want to do, don't do it. Print customer is bad, avoid, oh sorry, customer is good, please give him loan. If else, if else, else if decision equal to 1, print customer is bad, please do not give him loan. Yes, having bad record. Please do not give him loan. So like this we have made this, and let me see if it works. Okay, expected this. Okay, let me write this, no problem. Okay, here also we have to add this column, run. Customer is having bad record, please do not give him loan. See, it has come. Because we are having our prediction as 0, prediction as 1. So customer is having bad record, please do not give him loan. It will come. Now for example, let us, for the sake of it, let me write decision as decision equal to say 0. Let me change it and then see. Customer is good, please give him loan. So it is working. So let me remove this now. So like this we can customize it to predict our customers, whether the business is, we should increase business with this, we should give loan or not. Like this machine learning module can work, and this particular module can work as in the website also as a backend. We can make a website in which you have to input the details and the decision will come like this. So we can make a website out of this, or we can put it in the computer, or we can make a software out of it. So this is how we work in marketing to predict the credibility of the customer, whether to give loan or not, with the help of machine learning in Python. Thank you very much. If you have any doubts, you can please contact me. Thank you.
Okay, one more thing I want to say, that this warning is coming. X does not have this. This warning is coming because of here we have forgotten to write dot values. Here also we have to write dot values. And now again we run everything. Now the error should go. The warning should go. Let us see it again. It's running one by one. See, the warning has gone. So we can write dot values when we are defining x and y. Thank you very much for watching.